This is video 1 of just special considerations for Physics C students for the mechanics, and we're looking at some calculus and vector applications of Physics C. We'll start with separation of variable techniques to derive what I call the fabulous 5 equations. So we know that acceleration A is a differential dv dt. Now if we separate the variables, dv is equal to acceleration times dt. So we can perform a definite integral. We can integrate the left side with respect to velocity and the right side with respect to time. So the integral on the left is the integral of v naught to v final of dv. And on the right side we pull acceleration out because it will be constant. And that's going to be the integral of dt from 0 to t. And once we take the integral, we have v on the definite integral from v naught to v final, and then acceleration times time from t equals 0 to t. And we end up with the definite integral from v final minus v naught equals at, and of course we rewrite this into the familiar notation of v final equals v naught plus at. Now let's try another example. We now have this equation, v final equals v naught plus at. Let's write this as a differential. Well, what's velocity? Well, we know velocity is dx dt. And of course, we want to separate our variables, so we'll take dt to the other side. And then what do we have? Well, we have dx equals the quantity v naught plus at times dt. Distributing dt on the right side, we have dx equals v naught dt plus acceleration times time times dt. Integrating both sides, we're integrating dx from the definite integral from x naught to x, and the right side from t equals 0 to t. And that, once we evaluate, is going to be x minus x naught, because this will be x when we take the integral of it. This one, of course, is going to be v naught t, and the integral of this one was going to be 1/2 at squared once we place in our definite integral limits there. So that's the separation technique, separation of variable technique, to help us derive a couple of the Fab 5 equations. Now another consideration, a little bit of vectors. The vector dot product is used pretty frequently in AP Physics C. Let's look at two different vectors. Let's say I've got vector 1 is 5i minus 6j. Remember, I is for our x and j is for our y. And what about vector 2 is 3i plus 6j. And let's do the vector dot product. There's two ways of doing this. The vector dot product is going to equal the two x values, or the two I values multiplied by each other, plus the two y or j values multiplied by each other. So 5 times 3 plus negative 6 times 6, that of course equals negative 21. Now what's another way of doing it? Well, we can do a vector dot product by taking vector 1 times vector 2 times the cosine of the angle theta between them. But in order to do that, we need to use the Pythagorean theorem to get the vector's value, and also take the inverse tangent to get their angles. Okay, so vector 1, that would be the square root of 5 squared plus the square root, plus the square of negative 6. So we have 5 squared plus negative 6 squared, and that equals 7.51, or 7.81. Then we'll take the tangent of theta, which is 6 over 5, and that's 50.2. Notice how I did not include the negative there. So that's a vector of 7.81 at 50.2 degrees below the x-axis. Okay, because that has a negative y and a positive x. Now what about v2? We'll do the same. We'll take the square root of 3 squared plus 6 squared. That equals 6.71. And taking the inverse tangent of 6 over 3, it's 63.4 degrees. And I've located that here. This is our vector 6.71 at 63.4 degrees, and this time above the x-axis, because there is a positive x and a positive y. Okay, and then the angle between those, we add those two together, is 112.6. So now I'm going to take the magnitude of vector 1 times the magnitude of vector 2, and multiply by the cosine of the angle between the two of them. And we see that we get a negative 21. Okay, just like we did before. I do want to point out a special thing. If two vectors are perpendicular to each other, that means the angle will be 90 degrees. Regardless of which way we do this, you will get 0 for the vector dot product. So the vector dot product is useful to determine if two vectors are perpendicular to each other.